Uh, as we all know, Utah varies in a different climatic condition, and we are varying from different soil types. So we have all different soil type and all different climatic conditions. So based on that, we have like very good conditions over the very top, and we are suffering with the high water level table, and with the salinity issue. Then there are some areas where we are not getting anything. So based on that, I proposed an idea like idea of like spatiotemporal analysis of evapotranspiration disparity across Utah, which means like how evapotranspiration is gonna vary spatially, like within from north to south, and how it's gonna vary from year to year, like 2018 to all the way to 2023. Yeah. So, at the very first, what exactly evapotranspiration is? It's just simply the evaporation from the soil surface and the transpiration from the plant surface. So we have already used the OpenET data source, so we all know about that. So that's particularly software I use. So for that, from that, I have collected the evapotranspiration data from each county of the Utah. Like we have 29 counties, so I have collected evapotranspiration data for each county for continuous 6 years, like from 2018 to all the way to 2023. So in total, we have 29 counties, which means 29 sites and 6 years of data, which contribute to the 174 site years of data we have for the evapotranspiration. For easy access or easy way to understand what I have done, I have used ArcGIS model for its just to look over how it's varying spatially and temporally. That's what software I have used for showing the data. So this is the data from for the year 2018 and 2019. So this is the data of evapotranspiration in a whole year, like from the January 1st to 31st of the December. Here we can see like it's varying from 6.9 to all the way from until 46. Similarly, in the 2019, it's varying from 16 to all the way to 45. So here we can say that evapotranspiration is varying within Utah, like very low evapotranspiration is recorded in like these counties, and very high evapotranspiration is being recorded in these counties, like as we are getting to the south. And year-wise, we can also see there's a lot of difference. And these are the we can say the median of evapotranspiration, where maximum number of counties are getting into these this evapotranspiration rate. So we can get onto that. Like most of the counties fall in the range of 31 inches to the 34 inches of evapotranspiration. Similarly, we have data for 2020, 2021, and 2022 and 2023. So we have looked over like rapid calculation is varying according to the state really, like as we are moving in the counties. How about the time zone? Like during 2022, most of the counties fall in a region of like 31 to 37 inches of evapotranspiration. But in 2023, it's just the 26 to 29 inches of evapotranspiration. So we can say that evapotranspiration is varying spatially and temporally. So that's all we have covered. Like now we are going to use it is a base data for further analysis of what we have done for the further experiments. So this is the mean of 2018, how it's going to be if we take the whole year mean of the 2018 to all the way to 2013. So we can say that evapotranspiration is varying from 12 inches similarly to the 43 inches. And what we have seen, it's this trend. Evapotranspiration is increasing all the way from north as we move to the southwest. So there is an increase of evapotranspiration as we are moving from north to all the way to south, and we have also seen the temporal difference. There is a clear difference in the between the 80 of the drought years and the good precipitation years as we have seen. Based on that information, we all know how to download the growing period, and we all know what's exactly the growing period is. So growing season is just a period when a crop is grown and it's actually using the evapotranspiration for its growth. So we have already know the exact tool from where we have extracted data. So what I have done, from each county or each farm which I have collected the data, I have looked for the nearest weather station for that county and listed all of them and looked over the last freeze, spring freeze and the first fall freeze. So from here we can look over like there is a lot of variation in the free dates, like it's just 26th June to the to the 20th August. Here it's 17th of April to the 6th of November. So we can say that there is a lot of variation in the growing period. So using that data, we can look over like which county has a highest number of growing days and which county has the lowest number of growing days. As we move from the north to south, there is a increase in the growing degree days, and the lowest number of growing degree days are reported in the rich county, which is only 56 days of growing period days. And for these are maximum for the Washington County, which is 204 growing degree days. And the most of our counties in Utah fall in a range of 130 to 144 number of growing degree days. So based on that data, what we can do, like this is the exact time or this is the exact growing period when alfalfa is using evapotranspiration for its growth. So that what that exactly means, it is the actual evapotranspiration which is alfalfa using. Rest of is just the potential one which is alfalfa is not using. So based on that, based on that, these growing days, we are going to calculate the actual evapotranspiration. Similarly, we can see that uh, there is a spatiotemporal variation which we have earlier seen. So there is a variation, but what we have seen, it's like it's decreased from 6.9 to all the way to the 3.4 for the lowest county, and the 46 to all the way to only 28 inches of actual evapotranspiration, which is used by the crop. Rest is the crop is not using. And we can also see the temporal variation within the counties and within the years also. And similarly, we have graphs for 2020, 2021, and 2022 and 2023. And how about the mean? So for actual evapotranspiration, when we have calculated the mean value, so there is a variation among like there is a decrease in evapotranspiration about 12.35 inches of evapotranspiration. There is a decrease of that much evapotranspiration when we are moving from whole year evapotranspiration to just the crop what exactly alfalfa is using. So we can also see that most of the counties are using almost 16, 17 inches or 22 to 24 inches of evapotranspiration during their respective year or the average year. Where the rest of the evapotranspiration is going, that is what we call the potential evapotranspiration. So potential evapotranspiration is the what we call it, it's the maximum amount of water that could have evaporated and transpired if water was not limited in that particular county or in that particular climatic condition. So based on that, what we have done is like we have reduced the potential. We have reduced subtracted the actual evapotranspiration from the total evapotranspiration which we have calculated earlier and got the potential evapotranspiration and looked over the values like where they exactly falling like most of the counties are getting into the range of like 5 to 10 inches of evapotranspiration, which could be used if it was not limited. But what exactly for Utah? In Utah, it's is it like potential evapotranspiration or only potential evaporation? Here it matters. Like in Utah, it's only potential evaporation, not the potential evapotranspiration. If we move to the south or Midwest, then it's gonna be the potential evapotranspiration because in Utah, during when we get to the freezing days or freezing year, our plants are not transpiring anything. They are dormant, so they are not using any transpiration. So we are so alfalfa is only using the evaporation, which is being evaporated from the soil surface or during the snow years. So we can snow period, we can say that. So in Utah, it's only potential evaporation, not the potential evapotranspiration. It's going to be vary according to the region where we are. From that data, apart from that, what we can extract from that data, we can also look over the per day evaporation. How we have calculated it, it's like just simply the evapotranspiration during that particular growing period. We have divided it by the number of growing days. So that's the actual amount of precipitation each county is using per day, per day. So what knowledge gap it will fill up? Like we can get to the know like which county is consuming the maximum amount of evapotranspiration during the growing period, which county is using the minimum amount, which county is going to be the most benefited from the climate change as of an increase in the growing period of an ET, and which county is already using its maximum potential of growing period if only it is taken into the consideration. Here, similarly, we can look over the maps for 2018 and again 2019. So these are the values like how much exact amount of evaporation each county is using per day. So these values go back to the only 0.02 for the lowest one and all the way to the 0.38 inches of evapotranspiration per day uh, in the highest county. But what interesting comes here, it's like what we have seen, it's the graph is shifted all the way upside down. Earlier we are having the light color here and then all the dark colors here. But now it's shifted all the way up down. So now we can say that counties in the north is using way much evapotranspiration per day per growing period rather than counties in the south which are using evapotranspiration, less evapotranspiration per day, which is only 0.02 inches of water per day, which is way too high in north, which is 0.39 inches of evapotranspiration per day. Similarly, we have for 2020, 2021, and 2022, 2023. So in conclusion, we can say for the per day evapotranspiration, when we have concluded like for the average of, when we have taken the average, so we can say that which county is using 0.39 inches of evapotranspiration per day during the available degree days growing period of only 56 days, while the Washington County is using only 0.02 inches of evapotranspiration per day during the growing days of 204 days. So we can say that now we're going to answer all those questions we have marked up. So Washington County is already using its maximum potential of growing period potential in terms of ET, and which and Wasat counties can be benefited from the climate change based on only on ET. If all other factors are favorable for plant growth like soil, water, everything, but only on ET. But most of the Utah counties fall in the range of using the maximum growing period available, so we can't rely on climate change for more production or based on ET data. Thank you.